Welcome back. Wildfires are interesting. Geology plays a part in shaping, creating, and dictating the behavior of a wildfire, but wildfires also have an effect on the geologic environment itself. It's crazy, cyclical nature. It's the circle of life. So why is this geology? Let's find out. So why are we talking about wildfires and geology? Let's get into it. Extremely hot fires, as most wildfires can be, they actually leave a water-repellent layer of altered soil. As you burn material, it changes the properties of material. So you can kind of leave, again, this water-repellent layer of altered soil because of what you did to chemically change it during the wildfire. This increases the runoff and erosion in flood events, especially, obviously, in terrain that has steep topography, hills, mountains, and stuff. Wildfires can also, if coupled with storms later on, be cause for soil erosion and landslides. Because remember, if you're burning out the vegetation on steep slopes, you're burning out that root system, that anchor system, which could lead to erosion and or landslides in the future. And again, precipitation often exaggerates the effect of fires on landslides. Let's just say mass wasting events. Excuse me. I mean, not necessarily specifically landslides. My fault. So how does that occur? How can wildfires affect geology? In this case, looking at mass wasting events. So before a fire, you have the what's called litter, ground litter. That's the organic material such as needles, leaves, grass, brush, bark, the organic material that falls on the top of the soil. Then you have the subsurface soil, just the soil right below the surface. Well, once you get during the fire, you start to burn stuff. So that burning vegetation and litter, so soil particles coated with as you start to burn stuff, then the soil particles start to mix with that altered material. So you get soil mixing in and being coated with water repellent compounds. And then so after the fire, you have this subsurface soil, you have this new water repellent soil that you made, and all this ash and burnt material on top. So this ash and burnt material on top is very loose material. So if you get any precipitation, and even during Arizona monsoon, if we get a lot of rain real quick, all that material becomes saturated, and the layer right below the ash and burnt topsoil is water repellent, meaning the water can't soak in, so it just mixes with this material on top and just slides right off, just like a slide. This water cannot penetrate through that repellent soil, so it runs off just like water hitting concrete, just right off. This is exactly what happened during the Flagstaff Schultz fire. So there was a fire just on the slopes of the San Francisco mountains. That's the San Francisco mountain. That's the mountain, the stratovolcano or composite volcano in Flagstaff. We learned about a number of units back. So there was a wildfire on the slopes. You can see it occurring there. Well, you have steep terrain, altered soil, ash on top. Heavy rains came through the area. Excuse me. All that material, all that water mixed with that ash and burnt material, so caused what kind of mass wasting event? So you get a lot of water mixing with a lot of material, so you get this fast-moving stuff moving downslope with a big mix of all kinds of weird material. You know what kind of mass wasting event that would be? Debris flow. A debris flow. Probably started off as a flash flood, and as it picked up more material, morphed into a debris flow. So the origin of the wildfire occurred just north of Flagstaff. It was a campfire. Burned out along all of these slopes and even down on flatter areas. So the wildfire itself spared a couple of neighborhoods, but once a heavy rainstorm came through, the immediate next rainstorm, again, all that water mixing with the ash and burnt material flowing on top of that water repellent soil just came rushing down into these neighborhoods. And I don't think there was any deaths. I could be wrong, but I know there was a number of houses that got destroyed and flooded, and material coming into these neighborhoods. So it was kind of a big deal. So, in any case, geology shapes wildfires, wildfires shapes geology. The circle of life. We'll pause here. When we come back, we'll talk about some of the impacts wildfires have on society. See you back in just a second.